Equation of a circle. Consider a circle with centre 0, 0, and consider any point on the circumference of the circle with coordinates x and y. So it's maybe not the easiest thing to see at the minute, but if I was to add on a x-axis or an x-axis and also a y-axis, then hopefully that will make things a little clearer. So 0, 0 is the centre of the circle, and we've got each point on this circle is going to be of the form x comma y. In this quarter of the circle, all the points x and y are positive. In this portion, the x is positive but the y is negative. Here they're both negative, and in this part x is the only one that is negative. So in M4 we learned how to work out the length of the line. So if we're trying to work out the length of the radius, we could use this formula where it's x2 minus x1 squared plus y2 minus y1 squared and then square rooted. If we put in the coordinates, the x2 value would be x, the x1 value would be 0, and then the y2 value is y, and the y0 or the y1 value is 0. So what we're left with is r is equal to the square root of x squared plus y squared, because they just cancel out. And if we were to square both sides, we'd end up with r squared equals x squared plus y squared. And this is the general equation of a circle, which will have a centre of 0, 0 and a radius r. Now there's another way we could have established that, and it's using Pythagoras' theorem. So if we think about the radius r, and we form a right angle triangle, and because P has the coordinates x and y, this distance is going to be x and the height is y. And what we know about a right angle triangle is that x squared plus y squared is going to equal r squared. And that's going to be true for every single point on the curve. If we were to go down here, for instance, we'd have a minus x and a minus y. And whenever we square minus x, we get x squared, and when we square minus y, we get y squared. So we'll still end up with the same formula, with the same equation. And that will always have a centre of 0, 0 and a radius of r. So example 11, write down the centre and radius of a circle with the equation x squared plus y squared equals r squared. So what we know is that anything of the form x squared plus y squared equals r squared has a centre of 0, 0 and a radius of r. So this equation is of that form, so that means the centre is 0, 0 and the radius is going to be the square root of 9. Now how I'm getting that is that r squared must equal 9. So then r is going to be the square root of 9, so r is equal to 3. Part B, write down the centre and radius of the circle. 3x squared plus 3y squared equals 108. Now this is not of the form x squared plus y squared equals r squared, but to get it in the form of x squared plus y squared equals r squared, what we need to do is divide by 3. And if we do that, we'll get x squared plus y squared equals 36. Which is now of the form x squared plus y squared equals r squared. So this is going to have a centre of 0, 0, and r squared is going to equal 36. So r is the square root of 36, which is 6. So there's a centre of 0, 0 and a radius of 6. I thought I would just show you this graphically just to really reinforce it. What we've got is the equation plotted x squared plus y squared equals r squared, and we can see that it's a circle and the radius is 1. If I change this radius value to 2, then what we can see is that the radius is indeed 2. Now the fact that it would have on the equation is that you'd have x squared plus y squared equals 2 squared, which would equal 4. So that would be the equation there. And what we can do is we can slide this pointer along, and we can see that it changes the radius of the circle, and every time we do, whatever the R value is, that's going to be the height of the circle. So we can see it's at 6.9, so that means the radius is 6.9. Go here, we would expect it to be 8.4, and we can see the height of the circle is 8.4. We could see the width of it is at 8.4 and minus 8.4 and minus 8.4 at the bottom. So this is in fact the equation of a circle as expected. So a few more examples. So explain why x squared plus y squared plus 121 equals 0 does not represent a circle. So let's look at that. For the circle, it has to be x squared plus y squared equals r squared. And this equation is not in that form because there's number on the left-hand side. So what we're going to do is bring that over to the right, and we're going to have x squared plus y squared equals minus 121. Now what that would imply is that r squared equals minus 121. So to work out the radius, we would do the square root of minus 121. And one of the things that we can't do in maths, there's not an awful lot that we can't do, but one of the things we definitely can't do is find the square root of a negative number. So because we can't do this, that means that this equation doesn't make sense to us, because we can't find the square root of this negative number. So it's definitely not a circle. Next one, part D. A circle has a centre of 0, 0 and a diameter of 16. Now a diameter of 16, what we know about that is that the radius must equal 8. So we know the equation of a circle is x squared plus y squared equals r squared, and that circle will have a centre of 0, 0 and a radius of r. If our radius is 8 and the centre is 0, 0, then what we've got is x squared plus y squared must equal 8 squared, which leads to x squared plus y squared equals 64. Example E, show that the point minus 3, 4 lies in a circle with the equation 4x squared plus 4y squared equals 100. Now, this might not look like the equation of a circle, but what we can do is we could divide by 4, and we could have x squared plus y squared equals 25. So that is of the form of a circle. To show a point lies in a circle, what we need to do is we need to substitute in both points, both x and y, into the equation, and if the answer makes sense, then the point is on the line. If it's something that doesn't make sense, then it won't be on the line. So we've got minus 3 squared plus 4 squared should equal 25. Minus 3 squared, and negative squared is a positive, so we get 9. 4 squared is 16, equals 25. 9 plus 16 is 25, so we end up with 25 equals 25, which makes sense. So the point 3 minus 3, 4 is on the circle. Had we ended with something like 30 equals 25, well, clearly that's nonsense. So that would mean that whatever that point was not on the line. But because we end up with 25 equals 25, which is obviously right, then the point is on the circle. The other thing then we were asked to do was find the length of the radius. And in this equation, we've got x squared plus y squared equals 25. The 25 represents r squared. So r squared is 25. R is the square root of 25, which is 5. Part F, the point 2a lies in a circle with the equation 2x squared plus 2y squared equals 106. Again, we could divide by 2 here to get x squared plus y squared equals 53. So that's of the form of a circle. To work out the value of a, we substitute these in. So 2 is an x value, a is a y value. So we're going to have 2 squared plus a squared is 53. 2 squared is 4. A squared is a squared equals 53. We need to move the 4 to the other side, and to do that we'll take away 4 from both sides. And what we're left with is a squared equals 49. And then a is going to be the square root of 49, which is 7. Now you could potentially have had the plus or minus square root of 49 in that case. So we could have had 2 points, so 7 and minus 7.